Hey guys, we're back. We're gonna do 2.4. So we're gonna find the real zeros of polynomials. Now, in section 2.3, we found that we can use synthetic division to determine if a given real number is a zero of the polynomial function. But the truth is, if we were to test every given real number, we would be testing forever. So there must be a way to find possible rational numbers or rational zeros. So we're not just testing every number, 1, 2, 3, 4, 5, 1/2, 3/4, all those stuff. Those are rational numbers and real rational numbers. So we want to be able to make sure that we're guiding down the right path. And the way we can do this is from theorem 2.6, okay? So we have a polynomial with a degree n that's greater or equal to 1, okay? If R is a rational zero of f, then R is the form of P over Q. P is a factor, let me get my highlighter so you guys can see that. P is a factor of the constant of the term a sub 0, and Q is a factor of the leading coefficient of a subset n. Okay, so what we're going to do first is we're going to practice listing the possible rational zeros of f. So that means in this case, P equals -3 and Q equals 2. Now, you got to remember that this is the constant and this is leading coefficient, but P and Q are factors. So what are factors of -3? Well, plus and minus 1 and plus and minus 3. Whereas Q for 2 is plus and minus 1 and plus or minus 2. So there's a lot of different combinations that we can do. Okay, what does that mean? Remember that we are doing P over Q. So what I'm going to do, guys, is list one at a time. Okay, so I'm going to list them with plus or minus so we don't have to write them twice. So if I take P of 1, I can do 1 over Q of 1. So that's 1, right? I can do plus or minus P of 1 over 2. Okay, I already did the 1, so let's do P of 3, so plus or minus 3 over 1, because that's a Q. And we can do plus or minus 3 over 2. Okay, I'm not going to go Q over P. I'm not going to do 2/3 and 2 or 1 and 1/3. I'm only doing P's over Q's. So there are 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities in which we could use synthetic division to allow us to factor it down. Okay, so now what we're going to do is use these to break it down with synthetic. Now, of course, I would say try to use the easiest numbers first, okay? So, of course, I'm going to do positive 1, right? So, I'm going to have 1 as my factor, and then I'm using 2, -3, -8, -3. Do you guys see how I'm using the upper left-hand part? I'm not putting it in the middle because there are potentially 8 different synthetic divisions that we could do to find our factors. So I'm going to try to use as little space as I can. So 2, multiply, add, multiply, add, multiply, add. As you can see, the remainder is not a 0, so this is not a factor. Okay, so this is not a factor. So that was positive 1. Let's try negative 1. 2, -3, -8, -3. Bring down the 2. Oops, I guess that should have been over here. Multiply, you get -2, add, -5, multiply, add, multiply, add, and what do you know? We get 0. That means this is a factor. Now remember, it's opposite to what we see. So x plus 1 is a factor. Now, remember, what that means is that we can take what we already have and put that onto it. So this is your constant, your x squared. So we get 2x squared minus 5x minus 3. Now, could we use another synthetic division? Yes, but we are in an x squared, which means we can either see if it's possible to factor or if we can do the quadratic formula. You don't have to do any more synthetic unless you want to, but there's 6 more to test, so I wouldn't do it. Now, if we factor this, x plus 1 stays, and then we find that this factors out to 2x plus 1 times x minus 3. Some of you did the cross. Some of you said a times c. What 2 numbers do you multiply to give you that, but add to give you -5? There are different ways to factor. I'm factoring out quickly when it comes to the quadratic. If you need help with this, make sure you remind yourself to ask me questions. Now I can find the real zeros, because that was the whole point. So we have that x can equal -1. Middle one would be x can equal -1/2. And the third one is x can equal 3. Awesome. Good job, guys. All right. Let's see our next one. Okay. Make sure you give yourself some space, because we're at least going to do synthetic twice to get down to a square to be able to factor, okay? So let's remember, a subset 0, which is our p, is -8. So think of our factors of 8. We have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Then, as you can see, which is great, is that our a subset 4, or our leading coefficient, is 1, which is nice because that means q has to be plus or minus 1, which helps us out because it's only going to be 1 over 1, 2 over 1, 4 over 1, or 8 over 1. That includes negatives, by the way. So I don't have to write them all out if I don't have to. All right. So let's try one at a time. Let's start with that positive 1 there. So 1, -2, -7, 16, -8. As you can see, I want to double check that I'm not missing a term, because if you're missing a term, remember you have to plug in 0. All right, let's bring this down. Multiply, add, multiply, add, multiply, add, multiply, add. Yes, this means x minus 1 is a factor. Okay, so that also means when I factor that, I get, this is constant, this is x squared, x cubed. So I get x cubed minus x squared minus 8x plus 8. Now, be careful, okay? Because as you can see right now, we can't factor next to cubed. But we learned something about this at the beginning of this chapter, and it was multiplicity. Just because positive 1 worked right there doesn't mean now let me test -1. It means I actually have to test it again, because you can have it more than once, the multiplicity, right? So I'm going to keep testing that until I don't need synthetic or that it comes out to a remainder other than 0. So of course, remember, I'm going to use these coefficients right here. 1, -1, -8, and 8. Bring that down. Multiply, add, multiply, add, multiply, add. So yes, it is a factor. So there's 2 of them. There's x minus 1 times x minus 1. And then we have what's left over here. That's coefficient, and that's x, and that's x squared. So x squared minus 8. Okay. Remember, this also can be written as x minus 1 squared times x squared minus 8. So what does that mean about our zeros? Our zeros, real zeros, are x equals 1. And of course, that's twice, right? But we only have to put it down once. And then when we do this, we add 8 to both sides and take the square root. Remember, when you take a square root, it's plus or minus. So plus or minus square root of 8. Now, you can simplify that or you don't have to. I'm not going to worry about simplifying right now, guys. So plus or minus square root of 8. But be careful while you do the homework. If it's marking it wrong, it could be because it's simplifying. All right, let's do one more, okay? And this one was finding the real solutions, okay? I loved it because when we used to do a graphing calculator, we would plug this in and find out where they crossed, right? But now, no graphing calculator, so we have to use synthetic. So the first thing I'm going to do is move everything over. So we get 2x to the 5th minus 3x to the 4th plus 6x cubed minus 8x squared plus 3. That equals 0. As you can see, guys, when I subtract these over here, I automatically put them in standard form, so that way I wouldn't have to write things twice, okay? So let's talk about our possibilities. So a subset 0 is 3. Of course, the only factors of 3 is plus minus 1, plus minus 3. And then a subset, in this case 5, because that's the leading coefficient, is 2. So plus or minus 1 and plus or minus 2. Remember, this is P over Q. So we have plus or minus 1 over 1, plus or minus 1 over 2. Okay, and that gives us the 1s. Now let's go to 3. Plus or minus 3 over 1 and plus or minus 3 over 2. Yes, you could run into things that there's a lot more, okay? So just be careful and give yourself some room. And don't forget to check the multiplicities, okay? Now, one of the mistakes they made last year is that every time they tried a synthetic, they then erased it if they were wrong. Problem is, if your problem gets too large, you're going to forget what you tested and what you didn't. So just keep all that testing there, okay? Not to mention, if you make a small mistake, you have that work there that I can give you credit. So let's try positive 1 first. So I get 2, negative 3, 6, negative 8. Did you guys see this? There's no x to the first, so I have to put that 0 in, and then 3. I'm starting to make my synthetic really small, so I give myself some room. So to multiply, add, multiply, add, multiply, add, multiply, add, multiply. Yes, we got our factor of 0. Yay! That is x minus 1. Okay, now I'm going to go constant x, x squared, x cubed, x to the fourth. Okay, so I'm just going to write this so I know what I'm looking at so far. Plus 5x squared minus 3x minus 3. Okay, we still have to factor because I can't even factor out x to the fourth, so I need to keep going. Now, I'm not going to go down to -1 yet because I'm going to check the multiplicities, so I'm going to keep with the 1. And of course, don't forget, use these new values down here. So 2, -1, 5, -3, -3. Bring down the 2. Multiply, add. Multiply, add. Multiply, add. Multiply, add. Yes, it came out again. So there are actually 2 of these, leaving, let's see, constant x, x squared, x cubed. So I get 2x cubed plus x squared plus 6x plus 3. All right, then I would try it again, but I'm going to do this for you, okay? So we're running out of room. Once I do it again, I see that it's not going to work, so I know I keep my factor. Then I would try -1. I find out -1 doesn't work, okay? Now I'm going to go right in order so I don't lose track. Now I'm going to use +1/2. +1/2 does not work. You can try it if you want. Then once it doesn't work, I'll go on to the next one, which is a -1/2. So I'm using those values above, so 2, 1, 6, and 3. Bring that down. 2, multiply, add, multiply, add, multiply. What do you know? That one worked. Okay, so right now I have this x minus 1 squared times x. And remember, it's opposite, so +1/2 times, this is constant, x squared. So 2x squared plus 6. Okay, now, if I were to find the real zeros, remember real numbers mean they exist. So let me check. This one right here, we get x equals 1. This one right here, we get x equals -1/2. But if you look right here, guys, if we set this equal to 0 and solve, we would subtract 6, divide by 2. So that gives us -3. Then take the square root. Can we take the square root of -3? No, we can't. And specifically, we want real zeros, so we don't need to put that down. Now, let me remind you, because again, you are going to do a lot of work. There's nothing to get away from it, okay? So if you remember, I would have done 1 more 1. Wouldn't have shown that it worked. I would have done -1. That wouldn't have worked. So there's 2 right there. Then I would have done a +1/2. That wouldn't work. Then I would have done the -1/2. So there should be 3 more synthetic division tries that I would have made in there. Do not skip. The other thing is, some of you might want to say, oh, after 1, maybe I'll do 3 because it's a whole number. You can do that. But again, 1/2 is not that bad. But I definitely would have not done 3/2 until the very end anyways, because of that crazy fraction. All right, guys, take your time, watch your multiplication and your addition.